All right, everybody, welcome back. Now we are going to look at another set of problems that we can solve that include radicals. In the last video, we talked about how we could solve these kind of like normal, just undoing, and that our inverse operation for square roots were squareds. So now we're going to look at problems that are just different variations of the same type that might confuse you. So we're looking at a problem that says square root of 6n plus 10 is equal to the square root of 10 minus 3n. The first thing you should notice is there's now square roots on both sides of the equal sign. We also have n's in two different places. So those are the two things we want you to kind of notice, that we have variables on both sides of the equation, and both of them are stuck under the square root sign. Easiest way to take care of this problem is to get rid of that square root sign. And so we talked last video, to get rid of a square root, the inverse operation, again, is to square it. And whatever I do to one side, I have to do to the other side. So notice I'm squaring the entire side on both of these. Now the squared cancels out the square root, cancels out the square root, and we're just left with what was under the radical in the first place, which is 6n plus 10 is equal to 10 minus 3n. And now this is just back to a basic Algebra 1 solving equation with variables on both sides. The most common way we solve when there's variables on both sides is to get rid of one of them. We could subtract a 6n from this side, but I always like to get rid of the smaller variable just because we don't have to deal with negative numbers. So to get rid of a negative 3n, we're going to add 3n. Whatever we do to one side, we do to the other. So we're going to add 3n to both sides. And we're going to get on this side 6n's plus 3n's being 9n's. Still bringing down that plus 10 is equal to 10. Bringing down that one, and then canceling those out. And so now it's just a two-step equation, ones that you're super familiar with. So I'm just going to do it quickly, subtracting 10, getting 0, dividing by 9, and 0 divided by 9 is 0. So the n value that would have made this original problem true is 0. 6 times 0 plus 10 would have given me the square root of 10. On this side, 10 minus 3 times 0 is also 10. And so the square root of 10 is indeed equal to the square root of 10, and I know I got the correct answer. So to go back, if you have square roots on both sides, just start by squaring them both. And basically you're just ignoring the square roots, because if they're both being square rooted, the things under the square root have to be equal in order for the original to be equal. So that is one type. It's one of the simpler types, but students often get stuck because it just looks different. Now let's look at another type that's a little bit more advanced. Let's look at one that looks like this. So again, the directions are going to be solved. And it's going to be n equals the square root of negative 50 plus 15n. Now when you first look at it, it shouldn't look any different than the other ones. In a lot of ways you might think, why are you showing me this? This looks just as easy as the rest. I have an n here. Yes, I have an n in here. But I know how to get this n from under the square root. My first step is to undo this radical. And so to do that, I'm going to square both sides. What happens is something kind of strange happens. When I square this side, I also have to square this side. And so when I do that, I end up with n squared, which is the first time I had a quadratic term here, is equal to, and again, the square cancels out the square root. I'm left with negative 50 plus 15n. So in all the previous problems, I was left with a linear equation, just a regular undo, undo, undo problem. This one I'm left with a quadratic. And anytime you're left with a quadratic, you have options. You can solve with quadratic formula, you can solve by factoring, possibly taking square roots, completing the square, etc. I think this one looks like it could be factorable, but to be factorable, I have to set all of this equal to 0. So remember, when you want to factor or do the quadratic formula, you have to have it equal to 0, so the things on this side have to move over to here. So we're going to take care of that by moving the plus 15n over, by subtracting it. And at the same time, let's just move this negative 50 by adding it. Now again, whatever I do to this side, I have to do to this side. I'm not going to actually write down what I'm doing. I'm just going to know that I'm going to have to add 50 to this side, and I'm going to have to subtract 15n. So when I go to write the left-hand side down, I have the n squared. Now I could write plus 50 and then minus 15n. I could just write the plus 50 and the minus 15n. But because I know I'm going to be looking at a trinomial, I want it in standard form. I want to have the n squared term, then the n term. So after the n squared, now I'm going to write the minus 15n that I would have did to the both sides, and then I'm going to write the plus 50. Now I'm to the equal sign. Again, this was just moving that stuff over. And then this cancels and this cancels, leaving me just 0 on this side. And so now I have n squared minus 15n plus 50. This looks like it's possibly factorable. So I'm going to think, is there numbers that multiply to 50 that add up to negative 15? Yeah, there is. So 10 times 5 is 50. 10 plus 5 is 15. To get it to be negative 15, I'll make them both negative. And so I can factor this as n minus 10 times n minus 5. And I get answers of n equals 10 and n equals 5. And so it's quite possible to get more than one right answer. It is also possible that one of these answers don't work when you plug it back in. They're called extraneous solutions, but we'll look at those later. And so it is possible we get two answers. In this case, we got 10 and 5. Plugging in 10 in here, negative 50 plus 150 would give me 100. Square rooting it would give me 10, so that works. And the same thing would happen if I plugged in 5, and you can see for yourself. So there's times where it turns into a quadratic. And I just wanted to show you one more like that because they tend to be the trickiest for students. So let's just look at one more that looks like that in case you run into a problem similar to it on your practice. So if I said solve square root of 12 minus x equals x. And again, the directions would say solve. So I want you to stop in a second and just look at this. Think to yourself, if I was solving this, what would I do? I know my goal is to find an x value, so a number that I could plug into both these spots that would make this true. I mean, you could even start thinking of numbers like if x was 6. Would the square root of 12 minus 6, would the square root of 6 equal to 6? No, that wouldn't work. If x was 4, 12 minus 4 is 8. Is the square root of 8 equal to 4? No. And so you could start guessing and trying to figure it out. But instead of guessing, we can just use some basic algebra and just try to solve it, just step-by-step process. Again, the square root being the big problem. To get rid of square roots now, you should feel pretty comfortable of saying we have to raise it to the second power or square it, and also know whatever you do to one side, you do to the other. Now when this squared kills this off, just leaving me the 12 minus x underneath it, and on this side I get the x squared. The reason I picked this problem is just because of the way this worked out. The x squared now is on the right hand side. Usually say we want it to equal 0 over here, but it doesn't matter what side's equal to 0. I just know that in the end it's much easier if this x squared is positive. We've never factored with a negative x squared, so if I wanted to, I could like subtract x squared from here and subtract x squared from here, and it would equal 0, but I'd have a negative x squared, and I don't like that. So instead of moving this to this side, I'm going to move these two things to this side. So to move the x to the other side, I'm going to add it, because to get rid of a subtract x, you have to add x. Whatever you do to one side, you do to the other. And to get rid of this positive 12, I'm going to subtract 12. And when I subtract 12, that just moves to the other side. Now notice I just tacked it on to the other side because I can't add an x to an x squared, and I can't add a negative 12 to an x squared or an x because they're not like terms. So when I go to move these over, they change signs. And that's just kind of a basic rule. And what's left on this side after I do that is 0. So I have 0 equals x squared plus x minus 12. And once again, I'm looking at a trinomial that I can either use quadratic formula or factor. This one looks factorable, and I think most of yours today will be factorable. Are there numbers that multiply to negative 12 that add to a 1? Remember, there's a 1 in front of here, so we can just think of that as a 1. And I believe there are. 4 times 3 is 12. To make it negative, one of these has to be negative. To make it be a positive 1, it would have to be a 4 minus 3. And so we could say that 0 is equal to, and if I write this in its factored form, it would be x plus 4 times x minus 3. Finishing the solve, x is equal to negative 4, and x is equal to 3. Now in the last example, I started talking about what we called extraneous solutions. Extraneous, if I wrote the word extraneous, extraneous has a root word of extra. It's an extra extra answer that pops out that if you plugged it back into the equation, it wouldn't really work. And the reason we get extraneous solutions is based on how we kind of define square roots. Like if I said, what's the square root of 16? the square root of 16 is supposed to be positive 4. We're not supposed to think of it as a positive or negative. The square roots are supposed to be positive. When we solved something like this in the past, when we square rooted it, we did say plus or minus, but that's because we put the square root there and because we knew we had to work backwards. But if you just have a square root, it's supposed to just be the positive version. So one of these is going to give us an extraneous solution because it's going to pop out a negative answer. That's not true. So if I have the square root of something, it's not supposed to be negative. So this negative 4 is an extra solution that doesn't work because if I go back to this equation, I don't want to have a square root that equals a negative. And so like if you looked at the answer key, they would say that 3 is the only answer that works. And we could check it by plugging it in. Is the square root of 12 minus 3 really equal to 3? Well, yeah, 12 minus 3 is 9, and the square root of 9 really is 3. So 3 is equal to 3, and it works out. And so they would say 3 is the actual answer, not negative 4. And so just be careful of those extra ones. Oftentimes in radicals, the extraneous or extra solution is the negative answer. Not always, but most of the time. All right, I hope this helps. You can go back and watch the videos as many times as you need. You guys have just a few problems to try, and I will see you next week.